Hi, everyone. I know you're super excited to watch this fantastic lesson that I recorded on lesson 3.4, triangle coordinate proofs. It's going to be real exciting, folks. It's our first intro to proofs that we're going to do. So first of all, before we do our proofs, these proofs are going to be done on using the coordinate plane. So we'll need to refresh our memory on some formulas that we know, like the midpoint formula, distance formula, and slope formula. So first of all, let's take a second and let's write those out so we have them in one spot, and some of us get these formulas confused. So let's make sure we have them written right. Okay, so first of all, our midpoint formula is where we take x1, add x2, and divide it by 2, and then y1 plus y2 divided by 2. So midpoint, what do? You add them up and divide by 2. Okay, sorry, I was checking my sound was working. Distance formula is the one with the big square root. So we're going to take the square root and we take our difference of our x's, so x2 minus x1 squared. And then we're going to add the difference of our y's, so y2 minus y1 squared. That's our distance formula. And then we take the square root of those squares after we have summed them together. And our last formula is our fantastic slope formula. So that's y2 minus y1 over x2 minus x1. So midpoint, what do? Add them up, divide by 2. Distance, take the difference of the x's squared, add it to the difference of the y's squared, and take the square root. And our slope formula is our change in y over our change in x. Okay, so if we're working with coordinate proofs in triangles, basically there are 3 different types of triangles, or actually 4, that they could ask us to solve for. So the first one would be an equilateral triangle. Now, if a triangle is equilateral, it's a triangle with 3 sides that are equal in measure by definition. So if we had a picture, it would look like this. And I typed out my definition for you guys already, so you should write that down. A triangle with 3 equal sides, or 3 sides equal in measure. Now, if someone asked us to prove a triangle is equilateral, we could use one of our formulas that we have listed up above to show that the sides are equal in measure, and that formula that we would use would be our distance formula. So if I use the distance formula, it finds the lengths of the 3 sides, and by doing that, I could show that all 3 sides were equal in length, making the triangle equilateral. Okay, let's move on. Let's do our isosceles triangle. An isosceles triangle is a triangle with at least 2 sides equal in measure. Remember, equilateral can also be classified as isosceles. I'm going to draw this guy here, and 2 equal sides. It has 2 equal sides. Remember, it has 2 equal base angles also, but we wouldn't be asked to prove that on the actual coordinate plane. So again, if we're proving sides are equal in measure, we're going to have to use the distance formula again. So we'd have to use distance to be able to find the 3 lengths, and 2 of them are going to be equal, making it isosceles. Now, if it's scalene, that's crazy. There are no sides equal in measure. So none of the sides are going to be equal. Maybe it looks like this guy here, where they're all different lengths on the sides. So again, I'm just going to use the distance formula. And the distance formula would find the lengths of the sides, and then none of them would be equal in measure. Now, the spicy one is the right triangle. So a right triangle is a triangle that contains a 1 right angle. And there's actually 2 different methods that we could use to make a triangle right. If a triangle is right, we could use the slope formula to show that 1 pair of opposite sides are perpendicular. Because perpendicular lines have negative reciprocal slopes, and perpendicular lines intersect to form right angles, and a right triangle is a triangle with 1 right angle. You definitely need to write this whole entire thing that I have written here for method 1, because that would be a conclusion that we will be writing in our proof. And if you don't write it down in your notes, when it comes time to a quiz or test, you're not going to know where to find that definition. So make sure you're writing that down. Now, another method that we could use, method 2, could be to use the distance formula. We could use the distance formula 3 times to find the lengths of the segments. And then we can use our good old friend Pythagorean theorem with those distances that we just found to show that the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. I need some coffee. It's still early in the morning here. Okay. So now that we have our different types, we can prove something is equilateral, isosceles, scalene, or right, depending on the different methods that we pick there. Now, I don't care which method you pick to make something a right triangle. So if you like using distance and doing Pythagorean theorem, you can use that method. Or if you really love doing slope and getting the slopes to be negative reciprocals, you could use that method too. So I don't care which method you use to make something a right triangle. It's your choice on there. So let's look at our first example. When we're doing a coordinate proof, it's broken up into 3 different parts. It's kind of like an essay. I'm so excited. It's a math essay. So there's going to be an intro, which is your first step. And then there's a body, which is where you're going to do your work and show all your supporting evidence with your math skills. And then step number 3 is going to be a conclusion where you're going to write what you have discovered and justify your mathematics with theorems and definitions and postulates and things that we have already learned in class this year. Okay, so let's look at our first proof. It says prove, that's how we know it's a proof, that A is at 1, 1. So there's A. B is over at 4, 4. And then C is at 6, 2. So I want to prove this triangle ABC, oh boy, look at my drawing on there, is the vertices of a scalene triangle. Okay, so always important to figure out what you're trying to prove. Scalene. Now, since you're a math honors genius, you know that a scalene triangle has no sides equal. So none of these lengths that we're going to find are going to come out to be the same measure. So step number 1 is the intro, and in the intro it says you should begin by thinking of which formula. Now, if you remember back on our notes back up here, all of the beginning ones, equilateral, isosceles, and scalene, and even if you wanted to prove something right, you're going to basically use the distance formula for. So to make this scalene, or prove that it's scalene, I'm going to use the distance formula. Now, when you're using the distance formula, if you write out the formula once in your intro, then you don't have to write it all 3 times over again when you're doing the actual math. So I'm going to write my formula once in my intro, x2 minus x1 squared plus y2 minus y1 squared. And now that I've written that once in my intro, I don't have to write it each individual time as I do each side length. Okay, so now in the body, it says using the formulas that you chose, show all of the work, all of it. If you leave steps out, you're not getting full credit on a proof. Every single step has to be shown there to get justification to give you full credit. Okay, so I'm going to go and find the lengths of the 3 sides. So AB is going to be my first side that I'm going to find the length of. I'm going to use the distance formula. Notice how I labeled it as AB. If you don't label things, we don't know what side you're finding lengths of. You will not get full credit either. So I'm now going to take my coordinates. That's going to be 4 minus 1 squared plus 4 minus 1 squared. And I'm going to do my math. 4 minus 1 is 3 squared, and 3 squared is 9, and 9, that's square root of 18. And if I am a genius math honor student, I know that's really 3 radical 2, because 9 times 2 is 18, and the square root of 9 is 3. Okay. Now, I can be thinking ahead. Since it's scalene, the next side better not come out to be 3 radical 2, because if it does, then it's not scalene, and that would be naughty. Okay, so let's look at BC. So BC, I just take the letters in order, or you could wrap around the shape that you have drawn. BC is going to be 6 minus 4 squared plus 2 minus 4 squared. 6 minus 4 is 2 squared, and then 2 minus 4 is negative 2 squared. So I now have 4 and 4, which is radical 8. Remember, even though this is negative 2 squared, if you're one of those people who relies on your calculator to do math for you, if you don't plug that in with this parentheses around it, you're going to get a negative 4, which is naughty, because negative 2 times negative 2 is a positive 4 on there, people. So watch your writing on there, because we look out for those errors. This ends up being 2 radical 2 when you break it down. Fantastic. They're not the same. I'm 2 for 2. Now I just got to get the last side, which is AC or CA. And so that's going to be 6 minus 1 squared, and then 2 minus 1 squared. 6 minus 1 is 5 squared, and 2 minus 1 is 1 squared. So now I have 25 plus 1, which is radical 26. And radical 26 does not break down, and all 3 sides are not equal in length. Fantastic. Okay, so our mathematics there justifies that the triangle is scalene, and now I'm just going to write my conclusion. Okay, so in conclusion, we're going to summarize our work with some statements. Now we have to use definitions. Do you see that? If we're not using actual math definitions, theorems, postulates, things like that to justify, then it really is not a mathematical proof. I use the 3 dots. Maybe you've seen 3 dots before written like this. Those stand for therefore or in conclusion. So therefore, that I have discovered the length of AB is not equal to BC, which is not equal to CA. The 3 lengths are not equal. So now I know that triangle ABC is a scalene triangle. I like to start by repeating what they actually wanted me to prove. How do I know it's a scalene triangle? A scalene triangle is a triangle with no sides equal in measure or length. And sure enough, back when I found my distances, all 3 of them were not equal, and so I have thus justified that it has been a scalene triangle. That was super fun, wasn't it? It's like a little mystery puzzle. Like, is it going to be scalene? Is it not? Can you justify it with your math and use your definitions to prove that it's true or not? That was so fun. So that concludes our notes for right now, but you're probably thinking, look, there's an example 2, 3, and 4. These actually are going to be your homework, okay? So I put them in a PDF in your Google Classroom and assigned them as homework. If you're someone who wants to do them right in your note packet and take pictures of that and upload it into that assignment in the classroom, that is also fine too. So if you want to just keep working on your actual note packet here, take a picture and then upload it, that's fine, as long as I can see it there too. Okay, so let's just talk about these. To make it an isosceles, you're probably going to use distance again, remember? And don't forget, you have to have that intro, and then you have to have your body, and then you have to have your conclusion down at the end, okay? So if I don't see those 3 distinct parts, you don't get full credit on a proof, all right? So all 3 of those parts need to be there. So you're going to use distance 3 times again and make sure that it comes out isosceles. Let's go down here. Isosceles and right. Woo! It's a double proof. So it's not just one proof, it's 2 proofs. 1 to make it isosceles, 2 to make it right, people. So give yourself some room. Start out by making it isosceles. Do your intro, your body, and then your conclusion. And to make it isosceles, you'll do just like you did on the first one. You'll find your, look how I spelled conclusion. You'll do your distances 3 times. Now, to make it a right triangle, which is the second part, you're also going to do an intro, a body, and a conclusion. And if you look back in your notes, you can either do distances, which you already have 2 of them done to make it isosceles. So if you just found, or you actually have 3 of them done already. So you could just go right on and use the Pythagorean theorem if you wanted to show that the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So really, you did a lot of the work up here to make it isosceles. You could just go right into your Pythagorean theorem to show that that is making it a right triangle. And then down here, you're going to, given this triangle, find the measures of the sides. So you're going to use distance and then classify it. So you're going to decide, is it isosceles? Is it right? Is it scalene? All those things based on your findings from your measures of your sides. Okay, so I hope you enjoyed your fantastic notes on that section, and get proofing, people. I can't wait. See you guys soon. Bye.